So today we're going to have a look at Pythagoras Theorem. So we need to recognise that when you have been given a right angled triangle which involves only lengths, you are going to have to use Pythagoras Theorem. And that is a squared plus b squared is equal to c squared. If we draw out a triangle with our right angle, we know that c is our hypotenuse. This is the longest length in your triangle and is always opposite the right angle. A and B don't matter, so we could have it this way round, or we could have it this way round. It's not going to affect your answer. So now we know our formula, and we can recognise that our first question is Pythagoras because we've got two lengths and it's asked us to work out the missing length, AB. We can now label up our sides. So I'm going to call the length AC this length A. I'm going to call CB this length B. And therefore my opposite length to the right angle, my longest side, my hypotenuse, has to be C. If we now write down our formula, which we have to remember in our exam, which tells us that if we take our A length, which was 14 in this case, and we square it, and we add it to our B length, which in this case is 9, and we square it, that's going to give us our answer to what C squared is. So now if we type this in our calculator, we would get 277 is equal to this C squared. Remember, they want to know what the length of C is. So to finish off our final step, we would need to square root in our calculator that 277. We would then get the answer 16.64331, and this keeps going on. We then check how it wants our answer given. So it tells us that it wants it to 1 decimal place. So therefore we always point to our first decimal place number, draw our line after it, and that tells us to have a look at our second decimal place. Is this 5 or more? No, it's less than 5. Therefore our answer stays the same at 16.66 centimetres. It's always good to do a sense check at the end of the question. Does it make sense that this length is 16.6 centimetres? Well, first of all, we know it's got to be the longest side. 16.6 is bigger than both 14 and 9, so that makes sense. So now you can pause the video and have a go at question 2 before I talk through it. Okay, so here in question 2, again we're going to start by labelling our sides. I'm going to label the length AB as A, and the length BC as B, and then the one opposite my right angle, my hypotenuse, the longest length, has to be C. If you'd labelled A and B the other way around, this is still perfectly correct. Using our formula now, we know we need to do A squared plus B squared, and that is equal to C squared. Again, we just type this in our calculator. That gives us that 509.38 is equal to this C squared. So we now square root our answer, and we would get 22.5694. That keeps going on. This time it wants us to give our answer to 3 significant figures. So we know our third significant figure is the 5. Again, we draw our line, we have a look at our fourth significant figure. This time it's larger than 5, so that means we need to round up. So then our final answer would be 22.6 centimetres. Finally, we do our sense check. We know that C has to be our longest length. Well, 22.6 is bigger than both 19.3 and 11.7. So therefore it makes sense. Okay, so here in question 3, It's still going to be a Pythagoras question, however they've disguised it in a different shape this time, and we need to read the whole question to understand where the Pythagoras part comes in. So it talks about the trapezium, and it wants to put a fence around the whole shape. And he wants to know if he has enough fence. Well, we know for the perimeter of the shape, we would need to add together these 4 lengths. You will notice that one of these lengths is missing. And we need to work out that length. If we draw in a horizontal line across there, you will now notice that we have got a right angled triangle, and we want to work out again our hypotenuse, our longest length. Well, we know from properties of a rectangle that this length here must be exactly the same as our bottom length, as opposite sides are equal, so that would be 10 metres. We also know that the total length of this shape is 18 metres, and up to the top of the rectangle here is 11 metres. Therefore, the height of our triangle must be 7 metres, because 7 plus 11 gives us our 18. So our next step, now we've worked out the 2 missing lengths in our triangle, we can use these to work out our hypotenuse length. Again, we can start by labelling up our triangle. A, B, and then our hypotenuse is C. So we now know A squared plus B squared is equal to C squared. Well, 10 squared is 100, 7 squared is 49, so we now know that 149 must be C squared. We always have to remember to square root our answer here. So we need to do the square root of 149 to work out what C is, which in this case is 12.206. So now we need to finish off by answering the question. It wants to know if he has enough fence. So we need to add together these 4 lengths. We've got 18 plus 10 plus 11 plus this 12.2. This is equal to 51.206. He only has 50 metres of fence. So therefore, he does not have enough fence. You'd need to write that communication for your 5th and final mark. Okay, so now's your chance to pause the question if you would like to have a go at this contextual question using Pythagoras. So here, we know straight away that opposite sides of a rectangle must be equal. So we have just worked out the 4 outside lengths. So we could work out the perimeter of our school playing field. However, it also wants you to work out the length of its diagonals. And we've got 2 of these diagonals. These diagonals are equal in length. So if we can work out the length of one diagonal, we know that we can double it to get the lengths of both diagonals. So here we have been left with a right-angled triangle, and we need to work out what our diagonal length is. So we know we're trying to work out C, our hypotenuse, the length opposite the right angle, and we've again been given our A and our B. So here we use Pythagoras. We need to do 52 squared plus 39 squared, and that is equal to C squared. Again, we just type these into our calculator, and that gives us a total of 4,225. That's equal to C squared. We remember to square root our answer to work out the missing length, which is equal to 65. So therefore, our length of one diagonal is 65. So if we want to now work out the total length of the 4 sides and its diagonals, we would need to do 52 plus 39 plus 52 plus 39 plus 65 plus 65 again. And this is equal to a total of 312 metres. Our final question. Again, if you want to have a go at this independently, pause the video now. So in this question here, we've again been given a trapezium, and it's asked us to calculate the length of A to C. So in order to work out the length A to C, we can see that we've got a right-angled triangle. We know what our length A is, we don't know what this length B is, and we don't know what this length C is yet. So, in order to work out this missing length C, we need to first of all work out what B is. So to work out what our length BC is, we need to first of all work out what our missing length from D to this new point I've created, E, is. We know what our hypotenuse length is, which is 10, in our right angle triangle AED, and we can work out the length of A to E. We know our total length is 9 centimetres. We know up to point E is 3 centimetres, therefore this missing length here must be 6 centimetres, because 6 plus 3 is equal to 9. So this time we've been given what A is, we don't know what B is, and we've been given what C is. So again we fill in our formula like before. We've got 6 squared plus B squared is equal to 10 squared. Again we can square our numbers, and this time we need to work out what B squared is. So in order to solve this equation, we need to take that 36 to the other side. So we need to subtract 36 from both sides. That'll leave us with B squared is equal to 64. So therefore B must be equal to the square root of 64, which in this case is 8. So now we know what our length E to D is, which is 8. We can fill in that B to C is also this length of 8 centimetres. Like I showed you earlier, we've got our right angled triangle, 9 is our length A, 8 is our length B, and we're trying to work out our hypotenuse length, C. So now we fill in A squared plus B squared is equal to C squared. We square our answers and add them together, and that gives us a total of 145. We remember to square root our answer to get our answer 12.04159. So we now read our question. It tells us it wants the answer to 3 significant figures. We know that our third significant figure is our 0, so we draw a line after it. That tells us to look at our fourth significant figure. We can see that it's not 5 or more, so therefore our number stays exactly the same at 12.0 centimetres.